Exercise 1.3, question number 1, Roman 4, y equal to x square plus 2x plus 2 raised to 3 by 2 upon root of x plus 3 bracket raised to 3 into cos x raised to x. Taking log on both the sides, we can have log of y equal to log of this of the type a upon b. That means log of a minus log of b. See here. Now, this is of the type log of a into b. It will be log a plus log b. We know that log a raised to p is always p log a. Therefore, log of x square plus 2x plus 2 raised to 3 by 2 will be 3 by 2 log of x square plus 2x minus 2. Also, log of root x plus 3 raised to 3 will be 3 log of root x plus 3, and log of cos x raised to x will be x log cos x. This minus sign will change the signs inside the bracket. Now we can differentiate with respect to x. 3 by 2 constant along with variable as it is, derivative of log of something 1 upon that thing, and derivative of that thing, that means derivative of x square plus 2x minus 2 will be, what is the derivative of x square? It is 2x, derivative of 2x is 2, and derivative of constant 2 is 0. So it will be 2x plus 2. 3 constant along with variable as it is. Now derivative of log of something 1 upon that thing. Therefore derivative of log of root x plus 3 will be 1 upon root x plus 3. Now derivative of root x is 1 upon 2 root x. Now this minus x log cos x. This function is of the type u into v. First function as it is, derivative of second one, plus second function as it is, derivative of first one. X, first function will be as it is, derivative of log of cos x will be 1 upon cos x, and derivative of this cos x will be minus sin x. Now second function log of cos x will be as it is, and first function, that is x, derivative of x is 1 here. Now this upon y will go to that side and will become into y. This 2 and 2, which is common from this bracket, 2x plus 2, that means 2 in bracket, x plus 1, this 2 and 2 can get cancel, minus 3 ones are 3, 2 root x in bracket root x plus 3, minus, and this minus into minus will become plus x, sin upon cos is tan of x, see x tan of x, plus log of cos x. But this plus sign will change because of this minus sign which is outside the bracket. So it will be minus log of cos of x. Now Roman 5 is y equal to x raised to 5 tan cube of 4x upon sin square 3x. Taking log on both the sides, we know that log of a upon b is always log a minus log b. But this is of the type log of ab now. Then it will be log a plus log b. Therefore log of x raised to 5 into tan cube of x will be log of x raised to 5 plus log of tan cube of 4x. This raised to 2 will come down and will become 2 log sin 3x. Similarly, this raised to 5 will come down and will become 5 log x. Similarly, this raised to 3 will come down and will become 3 log of tan of 4x. Differentiating with respect to x, now derivative of log of something 1 upon that thing, derivative of y is dy by dx. 5 as it is, derivative of log of x 1 upon x, 3 as it is along with a variable, The constant along which variable is as it is. Derivative of log of 10x will be 1 upon 10x. Derivative of 10x is sec square of x into derivative of this 4x, which is 4, minus 2 derivative of log of something 1 upon that thing. That means derivative of log of sine of 3x is 1 upon sine of 3x into derivative of sine 3x is cos 3x into derivative of 3x is 3. So this upon y will become into y now. This 5 ones are 5, 5 upon x it will be. 3 4s are 12. Now sec square means 1 upon cos square. This cos 4x and this cos 4x will get cancelled. Okay. This upon 10x, 1 upon 10x, that means 1 upon tan 4x, that is cot of 4x. We can write it as cos 4x upon sin 4x. This sec square means 1 upon cos square. Cos can get cancelled, and what remains here is sin 4x into cos 4x. But 2 sin 4x cos 4x can give you sin double. So to have here 2, we will write 2 in the denominator and 2 in the numerator. So now as this cos and this cos 4x will get cancelled, what remains here is 2 sin 4x cos 4x. We know that sin double theta is 2 sin theta cos theta. Therefore 2 sin 4x cos 4x will give you sin 8x. Now this 12 2s are 24 here, and minus 6 cot 3x as it is. In place of y, now we can write what is y here, x raised to 5 tan cube 4x upon sin square of 3x. Okay, this 5 by x, this 24 by sin 8x. Sin 8x will go in the numerator and will become cosec 8x, because 1 upon sin is always cosec. Minus 6 cot 3x as it is, hence the answer. Exercise 1.3, question number 6 now. Y equal to x raised to tan inverse of x. Now this is of the type function raised to function of x. So in this type of problems, you should take log on both the sides to solve the problems. Log of y equal to log of x raised to tan inverse. Tan inverse of x will come down and it will become tan inverse of x into log of x. Now taking derivative of log of y is 1 upon y, and derivative of y is dy by dx. See here. Okay. Now this is of the type u into v. That means first function as it is, derivative of second function, that is log of x is 1 upon x. Second function log of x will be as it is, and derivative of tan inverse will be 1 upon 1 plus x square. See here. First function as it is, derivative of log of x is 1 upon x. Log of x as it is, derivative of second function, that is tan inverse of x will be 1 upon 1 plus x square. So it will be, this upon y will go to that side, become into y. What is the value of y here? It is x raised to tan inverse of x. This bracket tan inverse of x upon x plus log of x upon 1 plus x square is as it is. Now Roman 7, y equal to sin x raised to x. Taking log on both the sides, we will have log y equal to log of sin x raised to x. X will come down and will become x log sin x, because we know that log of a raised to p is always p log a. Therefore log of sin of x raised to x is x log of sin of x. Now differentiating with respect to x, derivative of log of y will be 1 upon y dy by dx. This first function x will be as it is. Second function log of sin x, derivative of that is 1 upon sin x into derivative of this sin x is cos of x. Now this second function log of sin x is as it is, and derivative of first function, that is derivative of x, is 1 here. This upon y will go to that side and will become into y. x as it is, cos upon sine will give you cot of x, log of sine of x as it is. Okay. So what is the value of y here? Sin x raised to x. So in place of y we can write sin x raised to x. The inner bracket or the bracket is as it is. Okay. Now Roman 8, y equal to sin of x raised to x. Angle is x raised to x. So there is only one function here, that is sine function. The angle is interpreted in the form of two functions, but we can differentiate like that. Dy by dx is equal to derivative of sine is cos of the angle, derivative of sine theta cos of theta, into derivative of this angle x raised to x. To find the derivative of x raised to x, let us say x raised to x is u, taking log on both the sides, log of u equal to log of x raised to x. This x will come down and will become x log x. Now differentiating with respect to x, we will have derivative of log of something, 1 upon that thing, into derivative of u is du by dx. X as it is, derivative of log of x is 1 upon x. Second function log of x is as it is, and derivative of x is 1 here. X will get cancelled, 1 is as it is, and log x 1s are log x. Now this upon u will become into u. Therefore, derivative of what is u here? X raised to x. Derivative of x raised to x is, this u is x raised to x, 1 plus log of x. So we should keep in mind that derivative of x raised to x is x raised to x in bracket 1 plus log x. So we will write this cos x raised to x as it is. Okay. And derivative of this x raised to x is x raised to x in bracket 1 plus log x by this result. Okay. Now question number 2, differentiate with respect to x. Y equal to x raised to e plus x raised to x plus e raised to x plus e raised to e. Differentiating with respect to x, this function is of the type x raised to n. The derivative is n times x raised to n minus 1. What is that? N times x raised to n minus 1. That means e times x raised to e minus 1 it will be. Now this is x raised to x, derivative of x raised to x. According to the previous result, derivative of x raised to x is 1 plus log of x. So here it will be derivative of x raised to x is x raised to x in bracket 1 plus log of x. Now we know that derivative of e raised to x is e raised to x, and derivative of e raised to e, that is a constant, is 0. Hence the answer. Now Roman 2, y equal to x raised to x plus e raised to x. Let u equal to x raised to x and v equal to e raised to x. Keep in mind this plus sign is there. If you are taking log on both the sides, we don't have any result of log of a plus b. So in this type of problems, you should have u plus v, y equal to u plus v. That means you should interpret the y in the form y equal to u plus v. Now taking log on both the sides, log of u is equal to log of x raised to x. This x raised to x will come down into log of x. Log of a raised to p is always p log a. Now differentiating with respect to x, derivative of log of something, 1 upon that thing, derivative of this u is du by dx. First function x raised to x as it is, derivative of log of x is 1 upon x. Second function log of x as it is, and derivative of x raised to x, according to previous two problems, derivative of x raised to x is x raised to x in bracket 1 plus log of x. Now this u will go up, so du by dx will become u into x raised to x upon x plus this x raised to x into log of x in bracket 1 plus log of x. This is number 1. What is v here? V is e raised to x. Then log of v will be log of e raised to x. Now, according to the property, log of a raised to p is p log a. Log of e raised to x will be x raised to x log e. Log e, here base is e. So log e to the base e will be 1. So log v is here x raised to x. Differentiating with respect to x, we will have derivative of log of something 1 upon that thing. Derivative of v is dv by dx. We know that derivative of x raised to x is x raised to x in bracket 1 plus log of x. Now this upon v will go to that side and will become into v. So dv by dx is v into x raised to x in bracket 1 plus log of x. This is number 2. As the given function is y equal to u plus v, dy by dx is du by dx plus dv by dx. What is du by dx here? This u means x raised to x. See here, in bracket x raised to x upon x plus x raised to x log of x in bracket 1 plus log of x. And what is dv by dx? See here, this v. What is v here? E raised to x. See here, e raised to x plus x raised to x in bracket 1 plus log of x. Now dy by dx is x raised to x. This x raised to x log of x common. What remains here is 1 upon x log x. Okay, no. Here there is no log x to take out of the bracket. So if you are taking log x outside the bracket, then you have to mention that log x in the denominator. Here x raised to x log x is common. Therefore what remains here is 1 plus log of x plus this part is as it is. Hence the answer. Always keep in mind that if y equal to function raised to function plus function raised to function, then the problem should be solved by type y equal to u plus v. You cannot take log directly without putting here u and v here. Okay, you should take log separately for u also and for this v also. Roman 3, same type of problem. Y equal to log x raised to x minus cos of x raised to cot of x. Let u equal to log of x raised to x. Now taking log on both the sides, what we will have here? Log of u. See here. Okay. This log of u into that is equal to x log of x. Log of u is this x will come down after taking log, so x log of x. See here. Okay. Now in case of this v, log of v will be log of cos x raised to cot x. That means cot x log of cos of x, because log of a raised to p is a log of p. Okay, no. Directly also you can say that log of v is this cot x will come down after taking log, cot x log of cos of x. Okay. Now differentiating with respect to x, we will have this derivative of log of something 1 upon that thing. Derivative of u will be du by dx. First function x will be as it is. Now derivative of second function, that means log of x, it will be 1 upon log of x into derivative of log of x. It is derivative of log of x is 1 upon x. Okay. Plus this second function, that means log of x, will be as it is into derivative of this x is 1 here. This x and x will get cancelled. This u will go to that side and will become into u. Upon u will become into u after going to that side. X will get cancelled. What remains here is 1 upon log x plus log of cos x. Sorry, log of x only. This is number 1. Now here derivative of log of v, 1 upon v, derivative of v is dv by dx. Cot x as it is, derivative of log of cos x, what it will be? Log of some, derivative of log of something, 1 upon that thing. Derivative of cos x is minus sin x. Okay, now second function log of cos x as it is, and derivative of this first function cot x is minus cos x square x. First function as it is, derivative of second one. What is derivative of log of cos x? It will be 1 upon cos x. What is derivative of cos x? It is minus sin x. Now second function log of cos x as it is into derivative of this first function cot x is minus cos x square of x. Now this sin upon cos is tan into this cot, it will give you 1, but this minus sign will give you minus 1 here. Minus cos x square log of cos of x. This upon v will go to that side and will become into v. Now we have this y as u minus v. As y is u minus v, therefore dy by dx is du by dx minus dv by dx. What is du by dx here? See here, du by dx is u in bracket. U means, what is u here? Log of x raised to x in bracket this 1 upon log x plus log of x. So see here, this du by dx we are writing as log of x raised to x in bracket 1 upon log x plus log of x minus dv by dx. Check dv by dx. From 2 we can have dv by dx as v times. What is v here? V is cos x raised to cot x. In bracket we can take out this minus sign. Okay, so cos x raised to cot x, this minus dv by dx, so minus sign is there. In bracket what is this? Minus 1 minus cos x square x log of cos x. Minus 1 minus cos x square into log of cos x. This minus sign we can take it out and it will become 1 plus cos x square x log of cos x. This minus sign which we have taken out, and this minus sign it will become plus. Hence the answer, log of x raised to x in bracket 1 upon log x plus log of x plus cos x raised to cot x in bracket 1 plus cos x square x log of